Okay, so another topic we need to know about with 2D shapes is area. And so what is area? What are we talking about? Well, we know that a perimeter is around the outside. So in the example of a rectangle, what we've got is, say this is a football pitch. If we're going to mark the edges of the pitch, and this is 11 and this is 7, then we would add up the edges. So we'd add up 11, we'd add up 7, we'd add up 11, and we'd add up 7, and that'd give us our perimeter. Unlike perimeter, the area covers the middle. So we're going to cover the middle. So for example, you've got your football pitch and we want to re-turf the entire pitch. Then we're going to have to cover the entire pitch with turf. And so that is the difference between area and perimeter. The area is the coverage, the bit on the inside. And so unlike perimeter, we're not going to be adding things together. What we're going to be doing is multiplying two things together. So in the example of our area of a square and a rectangle, our formula that we need to remember is area is equal to length times width. Area equals length times width. In the case of a square, what do we know about a square? We know that a square has all the sides the same length. And so we've got 5 multiplied by 5 is going to give us 25. And so our area is 25. What about this rectangle? Have a go. So it's going to be 4 times by 6. And so 4 times by 6 is 24. And what are our units going to be? Well, let's say these are both centimetres. I'll change this here. So let's say this is centimetres, 5 centimetres, and this is centimetres, and this is centimetres. Okay, well, what we're going to have is 25 centimetres, but with a 2 here, because we've multiplied two different dimensions together, the length and the width. So we end up with a 2 above here, which means centimetres squared. Same here, we've got 4 and 6. That's going to be centimetres. And that's going to be a 2 as well, because that's centimetres squared. We've multiplied two dimensions together. And so that's 24 centimetres squared. If we have another example for you to practice, I'm going to be a little bit sneaky here. I'm going to give you a rectangle. And I'm going to say this is 112 centimetres. And this is going to be calculator work, so don't worry about this. And this is going to be 1.3 metres. Okay. There's a problem with my sum. The problem is that the units of both sums aren't the same. And so sometimes you may have to convert from one to another. It doesn't matter which way you do it. I would say probably it's easier to convert into centimetres, but you might find it easier to convert into metres. If we want to convert this into centimetres, how many centimetres are in a metre? Well, there are 100 centimetres in a metre, so I'm going to multiply by 100, and I'm going to end up with 130 centimetres. Once they're both in the same measurement, then we can times them together and we'll get our answer. So if I get my calculator open here and I do 112 times by 130, I'm going to end up with 14,560 centimetres, and I'm going to put my little 2 there. So it's 14,560 centimetres squared would be my answer. In metres instead, if I wanted to do that, I could make this into metres by making that 1.12 metres. And in this case, I do 1.12 times 1.3, and I'll get 1.456 metres squared. These answers are the same, just one is in centimetres and one is in metres instead. Depending on the question you get, might influence how you're going to answer the question. For example, if they said this is a wall and your paint covers a certain amount of metres squared, then we might want to convert them into metres first to make our lives easier. If it said it covers a centimetre squared area, then we're going to want to make it centimetres first. And it's all about what the question tells you to do. So, moving on from squares, we've got triangles. Triangles follow much of the same rules, except we're going to do one extra step. So for a triangle, the formula for the area is equal to length times width, and then all of that is going to be divided by 2. This needs to be a regular arrow like this, and then put a 2 here. Length times width divided by 2. Or half times base times height. So another way of writing this, so that you might see, is area equals a half base height, with the base being the bottom and the height being the left to the up to down bit there. So half base times height. And if you see two letters squished together, that means times. So if it helps you to remember it, it's a half times base times height, like that. So in this example, what would the area be? I'll give you a few seconds to work this out for both of these triangles. What do we think the areas for these will be? Okay, hopefully you paused the video. If you didn't, pause it now and then we'll go over it together. So 7 times by 8, we should be able to do without a calculator, is 56. And then half of 56 is going to be 28. So our answer will be 28 centimeters squared. Assume that all of these are centimeters. If I didn't put the units in, just imagine they're centimeters. Or put units squared if you're not sure what the units are. That's okay as well. So that's going to be 28 centimeters squared. Now, what about the second one? Well, we don't have a up to down measurement here, but we have this one. If you've got given a height, even if the triangle doesn't look like it uses that height, make sure you use this number. This is called the perpendicular height, but don't worry too much about that. We've got our 12 times by our 10, which is 120. Half of that will be 60. So this answer would be 60 centimeters squared, like so. And that's going to be the areas of our triangles. If you ask yourself, well, why is it half though? Well, if we take this and we copy it and we rotate it 180 degrees, we make a square. And so it's exactly half as big as a square would be, which is why we half our answer. And that works for all triangles, isosceles, equilateral, scalene, anything. As long as you've got a perpendicular height and a base to times together and half it, you will get the right answer. And so that is how you do the area of a triangle. We've also got areas of circles. Now, circles are a little bit more complicated, and there's a formula you're going to need to remember. That formula is pi, which I'll get into in a second, r squared. Pi r squared equals area. Now, you might ask yourself, well, what do any of those bits mean? Well, pi is given to you on the front of the exam paper, and pi is equal to 3.14 for the purposes of what we're using it for. It actually goes on forever, but for our purposes, it's 3.14 equals pi. So if you see this weird T with 2 stalks instead of 1, that's pi. It's 3.14. Radius on a circle is from the middle to the edge. So in this case, our radius would be 5. So I'm going to separate all these and explain what they all are. So r is 5. Now, I've got r squared. Well, what does r squared mean? Remember when we talked about our square? All the sides are the same. So if we go back to our square here, we had a 5. The other side is 5. So 5 squared means 5 times 5 and not 5 times 2, which some people might think. So 5 times 5 is 25. So in this case, r squared is equal to 25. So our final answer is going to be 3.14 times 25 equals our answer. So if we go on our calculator again, and as soon as we see circles, we know we're probably going to be using a calculator, is 78.5. And so our answer is 78.5. This is going to be centimeters again, squared. Okay, all areas are going to be squared. Now, this right-hand one is slightly different because I haven't got a line that goes from the middle to the edge. I've got a line that goes all the way across. That line is called the diameter. And we're going to use that when we do the circumference of a circle. But for an area of a circle, we need a radius. So how can I find the radius? Well, I know that if from edge to edge, going through the middle, is 12, half of that is going to be from the middle to the edge. So half of 12 is 6. So what I'm going to do, and you could do this as well, is I'm going to draw a radius in. I'm going to label it 6. So I know that the radius is actually 6. Going back to my formula then, I'm going to have 3.14 times by 6 squared, well 6 sixes are 36. So 3.14 times 36 on my calculation is going to be 3.14 times 36 is 113.04, which I'm not going to round. Make sure you don't round it too early. And that's going to be centimeters squared as well. Okay, so if I give you another one to try yourselves, and of course, if I ever go too fast, you can go back, pause the video and make notes. I'll give you some more to do. And I'm going to give you a diameter on this one and a radius on the other. let's say this is 11 and this is going to be 26. Try and tell me what the area of these two circles are. You've got 5 seconds to pause the video and I'll be back in a second. Okay, so we know that pi is always 3.14 for our purposes. So we've got 3.14 times by 11 squared. Now, what is 11 times 11? At level 2, you're expected to know 1 times 1 up to 12 times 12 times tables. So 11 times 11 is 121. So 3.14 times 121 is going to be 379.94. And that's going to be centimeters squared again, like that. Okay, now then, what about this one here? Well, we know that this is a diameter, and so halfway between 0 and 26 is 13. So the radius is going to be 13. And so what I've actually got is 3.14, make sure it's in black, yes it is, 3.14, oh it was in black and I just changed it to red. Very silly, there we go. 3.14 times by 13 squared, well 13 squared is a little bit trickier, so what's 13 times 13? You could have done that on your calculator and you should get 169. So 3.14 times 169 is equal to our answer. Well, what is that? We're going to put it on our calculator. 3.14 times by 169 is 530.66. And so that's going to be my answer, centimeters squared. And that would be my area for that. So very well done if you managed to get those areas correct. If you didn't, go back and relook over the formulas and stuff. It takes some getting used to. But the good thing about these is you can just make circles and pick radiuses and pick diameters and work out their areas. You don't need to be given numbers, you can just make them up. And you can do this with decimal numbers, you can do this with fractions, you can do it with anything. But for our purposes, we're going to stick to whole numbers for now. Okay, there's one more thing I'd like to show you, which I haven't put in here, but I can put it in here now. And that's called compound shapes. So this term just means a shape that you can't really define with words, similar to like a square or a rectangle or something. If we've got a shape that looks like this, I'm going to actually have to draw it with lines because otherwise I'll give away the technique. I'm going to draw a shape that looks like this. Okay, we could say that's an L shape, right? But there's no mathematical term for an L shape. So this is a compound shape. What we need to do is work out its area somehow. So if I put some measurements in, this is going to be 8 and this is going to be 15, let's say, and then this is going to be 20 and this is going to be 12. And this is obviously not to scale, but it doesn't matter. I've given you some measurements. We have to split the shape into shapes that we do recognize. So we could split it, for example, down here, or we could split it across here. I'm going to split it like this. So what I've got here is a rectangle here and a rectangle here. It could be a square here, it could be a triangle here, and we'll go into another example in a second. But I'm missing some information. If I label these two sides, or these shapes, I'm going to label this A, and label this B. I need to work out the areas of both, and then add them up at the end. So, for B, I can work out what B is. If I pretend A doesn't exist, I've got 12 width and 15 length, so I can do 12 times 15. Well, 15 times 10 is 150, and 15 times 2 is 30, so that's going to be 180. And again, I'm just going to assume these are centimeters. It could be meters, it could be millimeters, whatever it is. So, we've got 180 for B. But A, I've only got an 8 here, and I don't want to use the whole 20 because that's too long. So I need to work out what this length is going to be. Well, I know that this is 20, and I know that this bit's 12. So what's left to make 20? Well, 20 take away 12 is 8. So what I've actually got is a square here of 8 by 8. And so what is 8 eighths? Well, 8 eighths is 64. And so 64 centimeters squared here. And so finally, what I've got to do is add up A and B. Now you can use your column addition method. You can add up using a calculator. This would probably be on a non-calculator because the numbers are quite simple. So we have 64 and 180. I'm going to do this in column addition method. So if I go underneath, 4 plus 0 is 4. 6 plus 8 is 14. And then 1 plus the 1 is 2. And I'd obviously carry the 1 underneath like this. So 4 and 0 is 4, 6 plus 8 is 14, carry the 1, 1 plus 1 is 2, so my answer is 244. In this case, that's going to be 244, again, centimetres squared. Okay? Now, if I give you a different example and then get you to tell me the answer, I'm going to draw a shape. Let's say the shape looks like this. Okay, some sort of obelisk-like shape. And I'm going to say this part is 7, and this part is 10, and then I'm going to say that this part here is 4. Okay? Try and tell me what the area of this shape is. I'll give you 5 seconds to pause the video, have a go, and I'll be right with you. Okay, so we've got a shape that we're going to need to split. The way I want to split it, you don't have to split it like this, but the way I'm going to split it is like this. I'm going to make a triangle and a rectangle. This rectangle, I've been told 10 is this bit and 7 is this bit. So this is going to be 70. Again, I'm going to assume it's centimetres. It could be metres or anything else. 70 centimetres squared like that. Now, I know the height of the triangle is 4 because this little arrow's told me. But what do I know about the width? Well, I know that this is connected to this and it's the same length as this because this is a rectangle. So this is going to be 7 as well. So we've got 7 times 4, which is 28, and half of it, which is 14, because it's a triangle. So 14 centimetres squared. Okay? And now hopefully, without a calculator, you can tell me what the total will be. 70 add 14 is going to be 84 centimetres squared. And so my answer for this question is 84 centimetres squared. Just to drive home the point, the sort of things they will ask you in the exam, sometimes they will be a bit meaner, and they're going to give you a shape that kind of looks like this. They'll say something like, a silo with a semicircular roof needs to be filled up with grain. How much grain can be filled in the silo? Something like that. Or this is a window. How much glass are they going to need to fit in the glass pane window with a semicircular top? Okay. Give it a go. This is a little bit tougher. All the information you need to answer the question is here. And I'll be with you in a second. Pause the video, have a go. Okay, so firstly, I'm going to try and work out, I'm going to make a split, and my split is going to be here. I've made a rectangle and a semicircle. So let's call this A and call this B. I can work out the area of this rectangle B. I know the height, they've told me, is 11, and I know the width. If the radius is 6, then what would the diameter of this circle be? Well, double of 6 is 12, and so I know that the length of this side is 12. And so what I've got is a rectangle with sides 12 and 11, and so 12 times 11 is 132, and so it's going to be 132 centimetres squared, okay? And if any of this is confusing, try again when I've explained it, see if it makes sense after I've explained it, and try the problem again. Now, we've got to work out the area of the semicircle A. Well, if this was a full circle, what I'd do is pi times r squared. So I'd do 3.14 times r squared. R is 6, so r squared is 36. So we're going to have 3.14 times 36. Like that. And so our circle will be 113.04 centimetres squared. However, I haven't got a circle, I've got a semicircle. So whatever I do, I have to half it because I've got half of a circle. And so I'm going to divide it by 2, and that's going to be my final answer. So divided by 2 is 56.52 centimetres squared. That is A. So now I've got A, so 56.52 and 132. I'm going to add them together. So I've got 132.00, I've got 56.52. Going to do it in the non-calculator method. So we're going to do 0 and 2 is 2, 0 and 5 is 5. I'm going to put my decimal point in the same place. 2 plus 6 is 8. 3 plus 5 is 8. And then 1 plus nothing is 1. And so finally my answer is 188.52. And that would be centimetres squared. So very, very well done if you managed to get that correct. If that's a little bit tricky right now, go back over it, look how we do circles. And this is the sort of thing they like to ask where there's a bunch of shapes added together and we've got to figure out different methods to work out the areas of those shapes. Brilliant. Okay, so finally, we're going to do the difference between area and fit. The thing about area is about coverage. So if we have grass or paint or something like that, it can be made very, very small to fit in all these tiny little gaps and things like that. For something that is solid, say a solar panel or a roof tile or something like that, they have to go in specific ways. You can't break them apart into little tiny pieces because they won't work properly. And so we're going to have to use our knowledge to see how many will fit into a bigger space. And they won't explicitly use the word fit, so you have to kind of implicitly understand the difference between a solid and a liquid thing. So in this example, let's say we've got a roof, which is 8.4 meters by 3.5 meters. And we've got a solar panel that is 1.6 meters by 1.8 meters. And they want to know what is the highest amount of solar panels that will fit in this space. Okay, so what we're going to say is, firstly, decide which way you want to measure it. The question may say that you can rotate the solar panel. Great. We assume that we probably can because we're going to have to do a few different bits of maths. So let's say this is the length. What is the length of this panel? Well, the length is the longest one, so it's going to be 1.8. So let's start with length divided by length. So we've got 8.4 divided by 1.8. Okay, if we do 8.4 divided by 1.8 on our calculator, we get 4.666667. Be careful at this point. We can't fit 0.6667 of a panel into our space. So the only amount of space we can fit is 4. Don't round it up like you might be tempted to. We can only fit 4. If we tried to fit 5, just as an example, if you rounded it up to 5, if you do 5 times 1.8, we're going to get 9, which is bigger than the space we've got. So that won't work. We can only fit 4 panels that way. Okay. Then we divide the other two. So we go width divided by width. So we'll do 3.5 divided by 1.6 because we want to work out how many will fit in the space. So 3.5 divided by 1.6 is going to be 2.185 or 2. So all we're going to be able to fit is 2 panels. Now, if we can fit 4 panels this way and 2 panels this way, how many panels can we fit in total? Well, we would do 4 times 2 equals 8. So we've got 8 panels if we do it that way. Okay. So that's one way of getting the answer. We fit 8 panels in. But what if we don't want to do length divided by length and width divided by width? What if I want to do length divided by width and width divided by length? So if I do the other way around, length divided by width, I've got 8.4, but now I'm dividing it by 1.6. So if I do 8.4 divided by 1.6, I'm going to fit 5.25 in, which is going to be 5 panels. And then if I do 3.5 divided by 1.8, what I will get is 3.5 divided by 1.8. It's going to be 1.999444. It doesn't matter that it's very close to 2. I can only fit 1 panel in. So 5 times 1 is 5 panels. And so in this case, we can say that the highest amount of panels we can fit in is 8, because 8's bigger than 5. But we have to show both methods to show that we've understood that this is a question about fit, and we've tried to rotate the panel a different way and it hasn't worked. It hasn't made it easier for us to fit it in. So I'm going to change the numbers. I'm going to leave the solar panel the same, but I'm going to change the numbers and then get you to try and work it out yourselves. So let's say this instead is 11.4, okay? And let's say this is going to be 5.3. Okay, so try and work out what is the highest amount of panels we can fit into this space, assuming that they all have to be facing one direction, but we can rotate the panel if we want. Pause the video and have a go. Okay, so firstly, I'm going to do my length divided by length because that's what I'm used to doing. So in this case, it would be 11.4 is the longest one, divided by 1.8, which is the longest one. I'm going to take my calculator, do 11.4 divided by 1.8, and I'm going to get 6.333, or 6 panels. Then I'm going to do my width divided by my width. So 5.3 divided by 1.6 is going to give me a different answer. 5.3 divided by 1.6 is going to be 3.3125, or 3 panels. And so in total, I've got 6 times 3 is 18 panels that will fit in the space. Okay, that's one of my marks for working out here. If it's a 4-mark question, this might be worth 2 marks. Okay, now I've got length divided by width. So I'm going to do the long side divided by the short side. So 11.4 divided by 1.6. It may not change my answer, but it might. So we've got 11.4 divided by 1.6. There's going to be 7.125, so I can give it 7 panels in this way. And if I do 5.3 divided by 1.8 now, so short side divided by long side, I'm going to get 2.994, so it's going to be 2 panels this way. And so we've got 7 times 2 is going to be 14 panels. And so what we found out is that in this case, our length divided by length gives us the most panels, 18 panels. It might not always work out so perfectly, but that is how we distinguish between area and fit. Can the thing I'm trying to put in the bigger space melt down into a liquid form and then be filled in all these little gaps? For a solar panel, it can't be. So it has to be solid. It has to look the same as it is. So we can only rotate it. We can't shrink it down or melt it and make it a liquid. So, but for things like paint and turf and things that are very, very small that you can fit in little gaps, then we don't need to worry about fit. We just work out how much of one area can fit into the area of another. But that's the difference between area and fit. And that's the sort of questions you'll be given. And again, you can always just make up numbers and see if you can work out. Say you treat the panel as a solid object and you don't change these numbers, but you keep changing the numbers of the big rectangle, you can keep trying this out and seeing if it makes any difference. That you end up with a scenario where perhaps length divided by width is better than length divided by length. But always attempt these sorts of things. These are the sort of questions they will ask you in the exam about fit. And really, that's all there is to know about area in this level of functional skills level 2. Thanks for watching.